Hey everyone, I hope you all are safe and doing good. So in the series of learning C++ programming language, we are discussing functions in C++. In previous video, we have seen what are inline functions, right? Now in this video, we'll talk about what is recursion and what are recursive functions, right? We'll be discussing everything about this recursive functions in this video, right? And with example, with program and with real life example as well, right? And then we'll see coding exercises based on recursion, right? And then I'll give you one assignment also. Fine. Now, okay, let's discuss this recursion with a real life scenario. Suppose in my class I have like 60 students, and when I call one student, like I call Anjali, and Anjali will say like yes ma'am, or Anjali will come to me, right? Then I call like Vaibhav, same Vaibhav will say like yes ma'am and something like this. Then I say Jenny, then what you guys will say, like ma'am, you are calling yourself, and that's true because I am Jenny and I am calling myself Jenny, right? So this technique or this process is known as recursion. Yes, in program we have some functions, and if a function calls itself, then this technique is known as recursion, right? Suppose I have this like a function fun in my program, like something like this. Here I am writing something, and within this I am again calling fun. Here I write something. So this function is calling itself. This is function calling, so it will go to here. Then again execute this, again function calling, it will go to here. So this function is calling itself. So this technique is known as recursion. And this function fun is known as recursive function. So if function calling itself, then that function is known as recursive function. And the process or the technique of calling, the function calling itself, that technique is known as recursion. But this is not complete definition. I'll tell you the complete definition of recursion and recursive function. But first, let's understand this thing, right? Now, the problem here is, if I call some student and he or she will come to me, right? And then obviously I'll not call him or her. But if I call myself like Jenny, then how will I come to myself, right? It's like Jenny, Jenny. So how will I come to myself, or how will I say like yes ma'am or something like this? Because here the termination condition is, or when I will stop calling that student, once that student come to me or respond me, then I'll stop calling that student, right? But here I'm calling myself, then how I'm going to stop calling myself, right? How will I come to me, right? So here, one problem with recursion is what? How to stop this recursion? Because these lines will be executed again here, again it will call itself, again it will call itself, again it will call itself. So when to stop this? How to stop this? This thing is very important, and that is known as base case or base condition, right? So here we can set a base condition, something like this. After calling Jenny 5 times, I'm supposed to stop, like Jenny, 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 and then stop calling Jenny, right? So this is base condition in my case, right? So same, to stop this recursion, you have to put some base case or base condition, right? This thing is very important here. Base condition or base case, right? If you will not put a proper base condition or base case, then your program, your recursion will never stop, and ultimately you will get obviously that stack overflow error or something like this, right? So now if I call, what recursion is? So recursion is a technique in which function calls itself repeatedly until a given condition is met. This is kind of complete definition of recursion, right? And a recursive function is what? A function which calls itself repeatedly. That function is known as recursive function, right? Now why recursion? This thing is very important. Why this concept? So sometimes there are some problems like factorial of a number, Fibonacci series, and the tower of Hanoi problem, and the binary search, and the sorting algorithm, quick sort, merge sort, and those, divide and conquer problems we have, like n queens problem and backtracking problems, and these things. These problems are, we can solve easily with recursion. We can model the structure of these problems in a program easily with recursion, right? Rather than that iterative approach. So that is why to solve some problems, no, we use recursion. We will see this thing how, right? So a recursive function will call itself directly or indirectly through another function. Here the function is calling itself directly, or maybe this function can call itself indirectly with the help of some other function, right? That is also fine. So let's take this example. factorial of a number. I want to find out factorial of 5. So how you will write? This is a mathematical problem. Like obviously we'll write here 5 into 4 into 3 into 2 into 1. Right? If I write 4 factorial, what you will write? 4 into 3 into 2 into 1. 3 factorial, 3 into 2 into 1. Like this, multiply the number till you get 1. This is how we are going to get factorial of a number, right? So in general, what can I write? N factorial is equal to n into n minus 1 into n minus 2 and so on till into 1, right? Or can I write this 5 factorial something like this? 5 factorial is equal to 5 into 4 factorial. Can I write this? Because see, this is ultimately 4 factorial. 4 factorial is equal to this. So rather than this, I write here 4 factorial. This is true? Yes. So same we can write here n factorial is equal to n into n minus 1 factorial. Yes or no? Fine. And then again n minus 1 factorial, I can write something like this, n minus 1 into n minus 2 factorial. Right? So like if I have n minus 1 factorial with me, so I just multiply that with n and I'll get n factorial, right? And to find out n minus 1 factorial, if I have n minus 2 factorial, then I will simply multiply this with n minus 1 and I'll get n minus 1 factorial. Right? So here what we are going to do, what we are doing here, we are dividing that larger problem or complex problem into simpler or you can say sub problems. Right? So we can also say recursion is a process of solving complex problems by breaking it down into small sub problems. Right? So rather than finding out n factorial, now you have to find out only n minus 1 factorial. And for n minus 1 factorial, you just have to find out n minus 2 factorial, right? And just multiply with this n minus 1. So we are just simply breaking down this problem into sub problems, right? So this is what recursion, right? So obviously, if we write a program, then simply we cannot write down in a program the symbol, factorial symbol, right? So rather than this, we will use some function. So can I write something like this? For this line, can I write something like this, like factorial of n is equal to n into factorial of n minus 1, right? This is how we can like model this problem of finding factorial of a number. Fine. So see, factorial, we can define factorial as a function and this function is calling itself by doing like n minus 1. So this is what recursion. Can you write this program? But here one thing, I have told you one thing which is very important to stop that recursion is base condition. So first, to write a program, you have to find out what is the base case. Because this is recursive case. Here we are calling the function again and again. So this is recursive case. So what is base case? There are two things when you are solving a problem using recursion: base case and recursive case. Base case, when to stop that recursion, that condition. Recursive case, divide the rest of the problem, except that base case, divide the rest of the problem into sub problem and just call recursion, right? Now what is the base case here? When we are going to stop once we reach to 1, right? And by definition we know factorial, 0 factorial is 1 and 1 factorial is also 1, right? So once the number reach to like 1, just stop. This is the base case. So this case you have to write down to stop that recursion in program. So now pause the video and write down this program. And if you want to write down the basic or the syntax or the structure of this recursive program, then how we are going to write that thing? See, we just write here first obviously return type, then that recursive function, right? Here in recursive function we have two things. One is base case just to stop that thing and another is recursive case, right? That's it. This is the basic or the syntax or structure of writing recursive function. So now pause the video and try this program. So I hope you have done this. So now let's find out. Suppose I'm just creating a function factorial and here I am passing 5, right? Let's call this in cout, factorial of 5. but obviously you have to define this before calling. So let's define this function, and we just, what this function is going to return, simply that number num into factorial of num minus 1. That's it, and that we have already seen, this line. Factorial of n is n into factorial of n minus 1. That's it. So num into factorial of num minus 1. But when to stop this? You have to put definitely the base condition to stop this recursion. So if number equal to 1, in that case return 1, because factorial of 1 is 1. So return 1. This is the base condition, and otherwise return this num into factorial of n num minus 1, right? And factorial of 5. So let's run this and see what output we are getting here. Factorial of 5 is 120, and we know that's true, right? But here that one thing is what, like if I write factorial of 50, let's run this and see, it will give you 0, because that would be a very long number. So here what we can do is, rather than int, better to write here unsigned long, because the range of unsigned long is, it's very long, right? So that would be fine if you want to find out factorial of a long number, right? So better to use this thing here also, rather than int, the num return type or the array type of number, you can take unsigned long, right? I hope you got this. This is very simple, right? See how simply the code is readable, na? And it's very simple to write that, program the logic of finding a factorial of a number. We can easily model that. In English we have written that thing, and we can easily model that thing here using recursion, right? So this is beauty of recursion. Sometimes for some programs it would be the code would be very clean and simple to write and easy to understand, and easy to model that structure of that program into structure of that question or that problem into program using recursion, like here, right? So sometimes it's very easy to use recursion, but sometimes better to use iterative approach rather than recursion, because of, now if you don't put here the base condition correct, then it would be, the recursion would never stop, and it would be like give you stack overflow. Now let me just show you what is happening behind the scene, how to find out factorial of a number. See, so this is a program, right? First, you know how the function call works, that function called stack. So we have this stack, and first here we have like that one activation record for main function, because from here obviously the execution would be started main, and here we are calling factorial 50, right? So in main, after that one activation record for this function factorial, fine, would be pushed in this stack. 50 would be passed here. So in this, the local variable for this function is num, and num is 50. Now this condition true? No. So here return num into factorial n minus 1. So num is 50 into, I'm just writing in short term, fact num minus 1, that is factorial of, or rather than 50, obviously it would be very large, so let's just keep it 5 only, right, just for your understanding purpose. So here we are writing simply 5. In num we have 5, and 5 into fact 5 minus 1, 4. Means it will call again this function. So again one record, again activation record would be pushed for fact 4. This was fact 5. So you see, if in one stack there are 2 activation record for the same function, it means there is recursion, right? So here we have again num is 4, and it will return, because this condition is not true, so it will return 4 into fact of 3. Now fact 3 means again it will call the same function again itself. So fact, this is the activation record for fact 3. So now num is equal to 3, and 3 into fact of 3 minus 1, that is 2. So again it will call itself for this activation record is for fact 2. So here we have num is equal to 2. This condition is again not true. So 2 into, it will call again fact 2 minus 1, 1. So one activation record for fact 1. So right now num is equal to here 1. Now see, num is 1. Is this condition true? Yes, condition is true. So return 1. So this function will return 1. Where to return? Where you are calling this function? Here. So it will return 1 to here. So fact this is 1. So 2 into 1 is 1. Right? Now 2 into 1 is 1. But now this function will return this value where? We are calling this function from here. Right? So it will return this value 2 to here. So 3 into 2, this value is 2, 3 into 2 is 6. Now where this value would be returned? Here. So here we have 6, 6 into 4 is 24. Now where this value would be returned? Here. Because here we are calling, from here we are calling fact 4. So 24 into 5 is 120. So this is 120. Complete 5 into fact 4 is 120. Now where this would be returned? And this is after returning back, this would be popped from the stack. Right? After returning this is now, right? After returning from here, this would also be popped out. Like this would also be popped out. This one, after that this would be popped out, this would be popped out. And after returning 122, here main. Because we are calling here in main function 120. So this would be out of the stack, popped out from the stack. And just see out, and see out would be, here the answer would be 120. And return 0 means successfully, I mean the program completion. So this main would also be popped out from the stack, and that's it. Right? So this is how you will get 120 answer. Right? Now I hope you got this. What is happening behind the scene? The function called stack. How this is working in case of recursion. Right? And now see, if there is no base condition, then we will simply call again. Like this recursion would be deeper and deeper. Right? Like for fact, then 0, fact -1, -2, -3, something like this. And at some point of time, obviously the stack memory would be exhausted, out of space, and then it will give you stack overflow error. So this base condition is very crucial to stop the recursion. This first you need to identify base condition if you are solving a problem with the help of this recursion. Right? I hope you got this. Now second, let's discuss with the Fibonacci series. Let's discuss that thing. See, we have, this is the Fibonacci series. 0 and 1. At starting we have, like, sometimes they start from 1 and 1 and some start from 0. 0, 1, then addition of previous two. 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 8, 5 plus 3, 8, 8 plus this 13, 21, and like this. This is what Fibonacci series, right? The next term, if you want to find out, then the sum of the previous two terms, right? So if I want to find out this 2 would be like 1 plus 1, that is 2. So previous two terms. So if you want to find out n, fib of n, this is Fibonacci series, and this is like one term, which this is known as Fibonacci number. So if you find out a particular term n, then we simply write down here like fib of n minus 1 plus fib of n minus 2. That's it. Because if you want to find out fib of, like, n is what? 0, 1, 2, 3, 4, 5 or 6. For this, the sixth number you want to find out, that is 8. So that would be this number plus this number, right? But now how to find out this 5? This 5 is this number plus this number, and the 3 is this number plus this number. So obviously you have to find out fib of n minus 1 and fib of n minus 2, like this. So fib of, we have fifth term, and fib of fourth, something like this. And then again fib of 5 would be fib of 4 plus fib of 3. So same, we are dividing the problem into smaller sub problems, right? And by definition, fib of 0 is 0 and fib of 1 is 1. So here we have two base conditions, fib of 0, fib of 1. Fib of 0 is 0, fib of 1 is 1. So these are base conditions, and this is like, these are base cases, and this is what particularly this is recursive case, right? So see, here we are calling 2 times fib, right? So this is kind of like tree recursion, you can say. There are types of recursion. We'll see the type also in some other video. Now pause the video and write down the program for this Fibonacci series. So this was the program for factorial of a number. Now let's write for this Fibonacci series. I just want to print Cout and fib of, suppose same that we have done here, fib of 5, suppose. So I want to find out fib of 5, that Fibonacci number, right? Now obviously you have to define that function first. So that number maybe could be very long, so we can take unsigned long, the return type, or simply you can take int also, right? fib, the name of that function is fib, and here we are just taking a number, suppose n. So what it will return? Return fib of n minus 1 plus fib of n minus 2. But before that you have to put a base condition to stop this. So if this n is less than or equal to 1, then simply return whatever the number n. If number is 0, return 0. If number is 1, return 1. You got it? And the number should also be unsigned. Let's take unsigned long for this number, because obviously we will not find Fibonacci series of minus. So, okay, here we have error. It's minus, not underscore, right? Sorry, it's not minus, it's plus. Sorry, my bad. And here let's simply print return 0. So let's run this and see what output we are getting here. Here we have 5. What is that series? 0, 1, then 2, sorry, 0, 1, 1, then 2, then 3, then 5, then 8, then 13, and something like this. So fib of 5, like 0, 1, 2, 3, 4, 5. So here we have 5 only. Like this, if we find out fib of 6, then it will give you 8. See, right? So now you have to try run this program. Please check out how this is working, the behind the scene what is happening, right? And one assignment for you is, here I'm just printing for 6 that particular number, but till 6th term, I mean that in that series there should be 6 term. What is the Fibonacci series? Like 0, 1, 1, then 2, then 3, then 5, then 8. Something like this till 8 you have to print. So this is your assignment. You have to print that Fibonacci series up to a given terms using recursion. And if you want to check out how this is working, you can continue watching this video, otherwise you can stop. So at first, see how recursion is working here. We have fib of 6, right? Or rather than 6, let's take fib of, for smaller, let's take fib of 4 here, right? So here we will write fib of 4. Now what is happening? Fib of 4 means here this condition is not true, so it will call this and this. So it will call fib of 4 minus 1, that is 3, plus fib of 4 minus 2, that is 2. So this is like tree type of recursion. Now again fib of 3 we have, so this fib of 3. It will call again here, so fib of 3 would be divided here, like something like this. Fib of 2 plus fib of 1, and this would be something like this. Fib of 2 is 1 plus fib of 0, right? Now fib of 2, this would again be divided into fib of 1 plus fib of 0, and fib of 1 would be, obviously this is base case, so it would not be further divided, because base case is n is less than equal to 1, return n. So we got here for all the branches base cases. So fib of this 1, fib of 1 will return, this condition is true, n is 1, so return n. So it will return 1 plus fib of 0, it will return 0. So 1 plus 0, that is 1. So this would be returned here. So here now we have 1. This would be returned here. So fib of 2 is now 1 plus fib of 1, it will return 1. So 1 plus 1 is 2. So this 1 plus 1, 2 is returned here, and here we have now 2. Now for this branch, fib of 1, it will return 1, it will return 0. So 1 plus 0 is 1, so it will return 1, and 1 is here. Now 2 plus 1, that is 3. So 3 would be returned here, and fib of 4 is 3, right? So as you can see here, fib of 4 0, 1, 1, 2, 3. Fib of 4 is 3. So this is how that in Fibonacci series that tree recursion is working, right? Now what are advantages of using recursion? That already we have seen. Like some advantages we have already seen. The code would be simple and easy to read. Clean code we can write using recursion. It can simplify the code of complex problems into sub-problems, simpler sub-problems, right? Like those backtracking problems and Queen's problem, searching problem, sorting problem, traversing problem, DFS, BFS, those problems. In some problems, like we can directly model the structure of that problem into program using recursion, right? But the problem here is what? When to stop that condition. Sometimes this error generally we get when we use recursion in a program, that stack overflow error. This is the drawback of using recursion. This you need to handle, right? And sometimes, debugging is also difficult in case of recursion because of, there are so many levels of recursion or that function calling, that function call stack. There are so many levels that debugging would be a little bit tough, right? And performance overhead is also there, the pushing and popping of activation record. Rather than in some problems, it would be easy to use iterative approach, right? But for some problems, definitely recursive approach is better. So now I guess you got it, what are recursive function and how recursion works. In detail, what are recursion, because there are different types of recursion as well. Direct recursion, indirect recursion, head recursion, tail recursion, tree recursion, like this tree recursion, right? So that we will see in a separate video, but basics of recursion and what are recursive function, that I guess you got it, right? So in the next video, we will see 1 or 2 coding exercises for this recursion. So now I'll see you in the next video. Bye-bye. Take care.